Hi, everyone. Thank you for joining. My name is Kevin, and I'm heading up the data science consulting team at Genestack. I'm going to give an overview about challenges and our solution for clinical and omics data integration. Our agenda for this talk is pretty simple. We are going to talk about how to integrate omics and clinical data, how to explore and stratify patients using multi-omics data, and how to perform advanced biomarker discovery. Before we start, let me give a quick introduction to Genestack. We are based in Cambridge, UK, and we work with both small and some of the largest organizations, including Roche, AstraZeneca, Unilever, and Corteva. Our flagship product is Omics Data Manager, which is the result of our collaboration with industry leaders. And the motivation behind our solution is a gap between data lake and visualization applications. On one end, you have data lake, which tends to lack data standardization, data lineage, and metadata management. And on the other hand, you have data analytics and visualization tools, which tend to suffer from incomplete or low quality data. So the aim of our product, Omics Data Manager, is to address this gap by providing three things. First, single point of truths to structure and standardize different data types. And second, an integration layer to capture different data relationships. And third, an integrative set of APIs to empower downstream visualization tools. And as I set out at the beginning, now we will look at these typical challenges faced by translational researchers. The first one is how to integrate omics and clinical data. The main challenge here is data silos, where different omics data types and clinical data are organized in different systems and managed by different departments. And the second challenge typically is around vertical data integration, around how to connect different data types. Data silos makes it hard to track data relationships between study, patient, sample, omics data, imaging data, and so on. And the third challenge here is around horizontal data integration, which is how to aggregate data from different studies or sources. It's challenging primarily due to incompatible or insufficient metadata. So the solution that we have developed in Omics Data Manager is essentially an integrated or a virtual data catalog where, as you can see on this screenshot, you can bring in data from early research or from clinical trials, from public data sources, and you can capture the relationships between patients and multi-omics data. And you can also ensure minimum metadata standards across studies using templates, ontologies, and controlled vocabularies. Once you have integrated the clinical and omics data, the next common use case is in exploring and stratifying patients using omics data. And the first challenge here is a lack of patient-centric view. Often the data is organized around studies, not patients. This makes it tedious to get everything you want to know about a patient, such as all the associated samples, omics, and imaging data across time points. And because of the lack of patient-centric data model, it's also hard to build, track, and explore cohorts from multiple studies. And lastly, with the growing volume and diversity of omics data, we start running into scalability issues when doing interactive data exploration. So what we are doing here is leveraging the data model and search capability in Omics Data Manager to extend our study browser to a patient or sample browser. As you can see here, it shows a list of patients across studies and all of the data associated with them. You can then select relevant patients, say for a particular treatment or indication, and build a cohort. Once the cohort is built, you can easily explore it by performing interactive queries on the associated omics data. One important point to note here is that building all this user interface and visualization is actually the easy part. The hard part is actually in organizing the data and building a flexible and scalable set of APIs that drive this visualization. Which brings us to the next challenge about performing advanced biomarker discovery. A common challenge with visualization or GUI applications is that they tend to be restricted in terms of what you can do. It's typically limited to doing standard analysis, typically performed by non-technical researchers. And for doing advanced biomarker discovery, what you want is to enable data scientists to easily utilize bioinformatics or data science packages, say in R or Python. But sometimes it's hard to integrate them into the data analysis environment. And often your existing solution also tends to be tied to particular data types or data sources. So there is a disconnection between the application and a centralized data management solution. So our approach here is to build a set of flexible and scalable set of APIs that can essentially plug into any data science environment. They enable you to do custom analysis very easily and rapidly. For example, here is an analysis on the TCGA dataset. It only takes a few API calls to quickly generate insights into how a particular clinical and multi-omics biomarkers affect survival status. So in this case, as you can see, if you're a smoker, have a KRAS mutation, amplification, and overexpression, you are at a very high risk of lower survival. So I'll close out my short talk by encouraging you to join our industry collaboration. Building an omics data landscape is difficult and expensive. So there is a growing move towards building a common and industry standard solution rather than developing your own custom solution in-house. We want to strategically avoid common pitfalls and accelerate development. And two particular areas that we are focusing on right now are single cell and clinical omics data integration, especially for ongoing uh, in-flight clinical trials. This is an exciting time and an opportune moment for you to join the likes of Roche and AstraZeneca. So thank you so much for listening. If you are interested to learn more about our experience working with other organizations in building a more integrated and scalable omics data landscape, you can take a look at the recording of my presentation yesterday, or simply come to us to talk. So yeah, that's all from myself and the Genestack team. Thank you so much for listening, and I hope we get a chance to meet.